Hello, my name is Ardi and we are going to solve problem E3.8 from IRWIN's book. So the question is find V0 in this figure here using nodal analysis. So we have this circuit here and we are asked to find out V0. And also we are asked to use nodal analysis. Okay, so we need to use KCL at the essential nodes. Okay, let's set the bottommost node here as our ground, so that the voltage here will equal to 0 volt. We assume that is 0 volt. And then let's get the nodes labeled. So here we have the node VA. And here we have the node VB. And here we also have the node VC. And let's just assume the direction of the current. We have this current source, so I just assume following the arrow. So it's going up, then going to the right, and then here it's going down. This is going to the right, this is going to the right. I just follow this one. And for this one, I just assume it's going down. This is going to the right, and this also going down. Okay, and what else we can get from here? We can get it from this 12 volt voltage source. The negative terminal is connected to the ground, so this will be 0, right? And we have to be 12 volt here. So the node here, it has to be, the difference between this node and this node should be 12. So here we have 12 volt. Okay, and I think we are all set from this, and we can transform this circuit into equations by using KCL at VA, VB, and VC. Let's do exactly that. Let's do KCL at VA. KCL said that the sum of the current that goes in will equal to the sum of the currents that goes out. The only current that goes in is this one, so we will have 8. And then that will equal to, here we have this current here, which is 2. And then plus this current here that is going down. So we'll have VA minus 0. So that will be VA divided by 3. And then plus this current here, we will have VA minus VB divided by 6. I think that's all for this node. Okay, let's do some math here. Let's multiply both sides by 6. So we will have 48 here. And here we will have 12. And then plus 3 and 6 will cancel out into 2. So we'll have 2 VA. And then we will have plus VA minus VB. So here we will have 3 VA minus VB, and that will equal to 48 minus 12. That will be 36. Nothing that we can do further from here. Let's just save this equation as equation number 1. Okay, good. Now what else can we do? Let's do another KCL, but this time at node VB. Let's do exactly that. KCL at VB. What does KCL say? The sum of the current that goes in will equal to the sum of the currents that goes out. Good. And the only current that goes in is this one, and that is VA minus VB divided by 6. And then this current is going out, so we will have VB minus 12 divided by the resistance between them. So we'll have VB minus 12 divided by 6. Good. And then we will have plus, then we'll have VB minus VC divided by 2. Okay, multiply both sides by 6. And we will have VA minus VB is equal to, we'll have VB minus 12 and then plus 3 VB minus 3 VC. Good. And so we will have PA minus, what is this? Minus 1, that will be minus 2, minus 2 minus 3, that will be minus 5. So we'll have minus 5 VB. And then we will have plus 3 VC. And all of that will equal to minus 2. And let's save this as equation number 3. No, equation number 2. What did I think? Okay, now let's do another KCL, but this time at node VC. Let's do that. KCL at node VC. Again, KCL said that the sum of the current that goes in will equal to the current that goes out. The only current that goes in, no, there are two currents that goes in, this one and this one. So we'll have 2 and then plus this one here, we'll have VB minus VC divided by 2. And that will equal to VC minus 0, that will be VC divided by 1. Okay, multiply this by 2. We'll have 4. And then plus 2 and 2 will cancel each other. So we'll have VB minus VC. And that will equal to 2 VC. And so we will have VB minus 3 VC. That will equal to minus 4. And here, this is the third equation. So now we have 3 equations with 3 variables, right? And we can solve this using calculator. Let's set our calculator as equation solver, which is number 5. And then 3 variables is number 2. And we plug the numbers, so we'll have 3 minus 1. But for VC, that is 0. We have to be careful here. And that will equal to 36. Okay. And then we will have PA, which is 1. Then minus 5. And then 3. Then minus 12. Okay. And then for this one, we will have 0. And then 1. And then minus 3. And then minus 4. Good. Okay, we have the VA value, which is 14.54. What is VA? That is 15.44 44 or 54? 54. 54. 54 volt. Okay, and then what is VB? VB is the Y value here, and that is 7.63. 7.636 volt. Then what is VC? VC will be 3.88. Okay, 3.878 volt. Okay, and the question is to find out about V0. What is V0? V0 is just VC minus this voltage here, which is 0. So I'll have VC minus 0, which is equal to VC actually. So our V0 is 3.878. And the unit will be in volt. Okay, maybe the answer slightly differs because of the rounding error. So, but it's close enough, and I'm sure that is correct. I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.